Hey all, let's solve this Leetcode's famous problem which says Koko eating bananas. Let me see when's the last time I solved this. It's Jan 2026. It's been 7 months, so let's break down the problem and see how we can approach towards the optimal solution. Let me reset the timer. Let's start. Koko loves to eat bananas. There are n piles of bananas. At piles of 5 bananas. The gods have gone and will be back in 8 hours. Okay. Can decide her bananas. Eating speed of K. Each hour she chooses some pile of bananas and eat K bananas from that pile. If pile has less than K bananas, she eats all of them instead and will not eat any more bananas during this hours. Koko likes to eat slowly but wants to finish eating all bananas before God returns. Minimum integer K such that she can eat all bananas within each hours. So let me explain the problem statement first. So we are having an array piles which shows every pile of is pile of 5 bananas. Every pile has pile of 5 bananas. Now the workers or security guards who stay there went out for something to have snacks or tea. They will come back in H hours. In this H hours, Koko is a monkey. Let's suppose Koko should eat all the bananas within H hours. So there is a constraint that Koko can eat K bananas per hour. So Koko can eat K bananas per hour. Now we need to check what is the minimum value of K such that she can eat all the bananas in all the piles in H hours. And if a pile has less than K bananas, Koko can eat all at once. It simply means like to eat any, if pile of 5 less than K, it is considered as 1 hour in simple terms. If pile of 5 equals to K, it also takes 1 hour. If pile of 5 greater than K, now number of hours it takes. If it takes simple distance time formula, if the speed is K and distance is pile of 5, what does time mean? Distance by speed. Pile of 5 by K. Now here we are measuring it in times, which is hours. So we can't eat another pile in the same hour. Got it? If Koko started eating ith pile, till the hour completes, she can eat ith pile and stay at rest. So we need to take seal of pile of 5 by K. Got it? Now how do you decide the minimum value of K which satisfies all these conditions? So given constraints, pile of 5 can be till 10 power 4 and hours can be till 10 power 9, and piles of 5 can be till 10 power 9. So the brute force approach let's leave constraints and everything aside. When I look at the solution, it's simple. I'll go to each pile. I'll have a k value. So the minimum k value possible is the minimum k value possible is minimum number of bananas, because if I have k value as 1 and the minimum number of bananas are suppose 6, what is the point of having 1 2 3 4 5 as a minimum number? It always takes more hours. Let me frame it in the right way. Eating speed k. 1 can also be possible, right? Yeah. So minimum k value possible is 1. Koko can eat at least 1 banana per hour. Since they said that k can be the integer, we cannot take 0.1, 0.2, all those things. Now what is the maximum k value we can consider? It is since h greater than or equals to length of h greater than or equals to length of piles. What does this mean? K can be, if k is the maximum value of piles, it can eat Koko can eat all the piles in length of piles hours. H is always greater than or equals to length of piles. So maximum k value we can consider is max of piles. Hope you got it. Let me keep it simple. So to achieve the target minimum, at least Koko should eat 1 banana per hour. To get maximum, Koko can eat k values, which is max of piles. If Koko can eat max of piles bananas per hours, Koko can complete it in length of piles hours. And here we are given that h is always greater than or equals to len of piles. So we can restrict it to max of piles. There is no point of checking all those towards left. Now I will traverse for all k values from 1 to max of piles. I will check amount of hours taken. For the minimum possible k value, which meets check number of hours, minimum possible k value where number of hours is less than or equals to h is our required answer. Now what is the complexity of this solution? O of max of piles for k, and for each yeah, of max of piles. So piles can be till 10 power 9. So the answer can be our complexity is till 10 power 9. Is this optimal? No, it is not optimal. Yeah, solution might get passed because of 10 power 9 is fine, but this is not optimal. Why? Because if you look this, we are doing a linear search of all the k values and we check whether it satisfies the hours or not. Instead of doing that, can we do binary search for this? Linear search is O of n, and can we reduce this to O of log n is the key challenge here. Now left will be at 1 and rightmost will be at max of piles. Now to do binary search, we'll be having mid, which is left plus right by 2, and we'll check if it is possible to achieve h hours if we take k as mid. Look at the statement properly. If it is possible to achieve h hours, it means hours taken if k equals to mid must be less than or equals to h if it is possible. Now here the key thing is we need minimum k value which satisfies. Now this is one of the possible result. We store it in a result. Now to check if there is any minimum k value which can even satisfies the thing, we move height pointer towards mid minus 1. Now if it is not possible to achieve h hours at mid, then we have an assumption that there might be any pointer towards right which can satisfy this. So we moved left pointer towards mid plus 1. Mid plus 1. Height, let's keep it as mid. At the end, what will be the result? The highest value which satisfies, which is h. We just return highest pointer. Now what will be the complexity of this? We are not verifying at every level. We are doing binary search at the mid pointer, so it would be of log of max of piles. And to check if it is valid, it takes more time, often. Similarly here I have missed it. To check that the k value satisfies, it takes m more, which is the length of piles. Do we need any extra space here? No, we just traverse using 2 pointers left and right. Got it. Now let's go into the implementation phase. Let's take m is n. Let's keep it simple. Piles dot size. Got it. Now we have left pointer towards 1. 1. Right pointer towards max of piles. Piles is an vector int, so star max underscore element of piles dot begin comma piles dot end. Okay, Okay, now how do you choose? Should the left be less than or equals less than right, or less than or equals to? How do you check that? If left is less than or equals to right, then mid will be the height itself. We have already checked the height which satisfies, then we move height to, let me keep it simple. We already check if that k value satisfies, then only we will move height to mid, right? Now again, if we check mid again, here we are doing a duplicate operation. We have already checked that mid value and assigned height to that mid. Again, if we get the same mid value as same mid value, height will again point towards the same mid, so it will be a recursive loop. So we just need to check till left is less than right. I hope you got this. And now we take mid left plus right by 2. Right, now key thing, if valid of mid comma, we just need to send piles and edge. If valid of mid and piles and edge, if it is valid, we are pointing height towards mid, else we point left towards mid plus 1. At the end we return height. Oh sorry, we took it as right, so let's keep it right. Yeah. Now how to check if it is valid? To check if it is valid, we need bool valid of int k comma vector int and piles comma int h. Got it. Now how do you know that it is valid? Simple. We traverse through all elements in the piles and we check the hours. So initially hours is 0. For int pile in piles, what is the hours that it takes? Hours plus equals to, as we discussed, it will be the seal of pile of I by k, pile by k. Okay, if it is less than or equals to, it will automatically, seal will automatically convert it to 1, so we don't need to write explicit. We just take return hr is less than or equals to h, then it is valid. Now let's run. Three, are they asking in the one index format? 12 30. What is issue here? Okay, it's 11. If we take it 11, is 0. Let me print k. And hover here to check how it is really checking it. So we have k as 6 first. If we take 15, it is 4. How come it is 4 if we take 15? Pile 30 by 15, 2, 1, 2, 1, 1, 2. How come it is 4, right? If we take 15, how does HR is 4? Let me print pile so that I can understand what is the issue here. Pile, yeah. Three, 6, 7, 11, 30, yeah. We also print this, right? K pile by k. Something is issue here. Let me check. Let me check this. 52. How come it is 0? K is 15, pile is 11. CL of 11 by 15 should be 1, right? Double. I think this is the issue. Double of K. We need to do it double before we are doing division operation here. So yeah, it works. Let's remove these coutts. If you look here, we don't need to wait till all the hours are completed. If in between hour becomes greater than h, we just return false. We don't need to check more. Let me test this. Yeah, let me submit. Yeah, it works. I don't mind this run times. Even the top solution is the same. Max of piles 1 high. Yeah. So in simple terms, we are given piles of 5 piles array where piles contain piles of 5 bananas. We need to eat all the bananas in h hours. We need to find the speed k such that we can at most eat bananas from one pile and we can eat 8k bananas per hour. So to do that, we can do linear search, but complexity is O of n star m, which does not suit this, so that we'll move it towards O of n star log m by doing binary search. That's it. uh, the key thing is here understanding how binary search is applicable to do linear search for each to check if it is valid or not, because this pattern repeats a lot in contests, and also you will eventually learn how to use binary search to apply other data structures. Thank you.